Hey guys, we're going to wrap up this section on exponents and exponent laws by exploring something that occurred at the very end of your classwork the other day. If you remember, there was a division problem and the answer ended up with a negative exponent. So, based on that, we know that negative exponents must exist. So our job today is to, one, understand what do they mean, and two, be able to simplify an expression that has a negative exponent in it. Okay, so with that in mind, let's get right into it. Okay, take a look at the following two expressions with exponents. Now, I think most of us will agree that the one on the left that says 2 to the third just simply means 2 times 2 times 2. But if I was to ask you that same question about the one on the right, I would get probably a bunch of different answers. I know some people would think it means negative 2 times negative 2 times negative 2. But it doesn't mean that. That's what this would be. And those aren't the same thing. So the question then is, well, maybe then this is just whatever I get when I multiply 2 times 2 times 2 3 times, and then I make it negative. That's not what that means either. In fact, this negative exponent has nothing to do with the answer being negative at all. So with that in mind, then let's explore a problem that we know the answer will end up negative, and maybe that will lead us to understand what that negative exponent does. Okay, so let's look at a simple problem. We'll look at a division problem. Now, when I go to do this problem, it's 2 squared divided by 2 to the 5th. According to my laws of exponents, I should keep my 2 and subtract my exponents. Now, if I need to, I go to a calculator there. 2 minus 5 is not 3. 2 minus 5 is negative 3. So the answer to this is 2 to the negative third. Okay, that is the answer when I apply the law. Nothing I can do about it. But let's get a better understanding of actually what does it mean to have a negative exponent. And we're going to do that by the same way we've been doing it in every one of the other lessons. Let's expand out our exponents. So 2 squared is 2 times 2. 2 to the 5th is 2 times 2 times 2 times 2 times 2. Well, just like we would have done the other day, if we have something on the bottom that can cancel with something on the top, we're going to do that. If we have something on the bottom that can cancel with another something on the top, we're going to do that. And it looks like we've canceled out everything there is on the top. Now, when you do that, you're just left with the number 1. But look at what we have on the bottom. 2 times 2 times 2, which when written as an exponent is 2 to the third. So it looks like the answer to this is going to come out to be 1 over 2 to the third. And it is. Now, if I wanted to evaluate that and do the math on it, I could also say that the answer is 1 over 8 because 2 times 2 times 2 is 8. But now what I've just seen here is that 2 to the negative third is equal to 1 over 2 to the positive third. And that's actually going to be a law. And that is how you simplify it. We'll explore that more on the next slide. Okay, our final law of the exponent laws is that one about how do you simplify a negative exponent. And it is simple as what we just saw there. If you have an exponent that is negative, you can simply write it as 1 over that exponent as a positive exponent. So x to the negative b can be rewritten as 1 over x to the positive b. Now, we may start to then take a little shortcuts with our definition and go, oh, I just took it and moved it down into the denominator. Yep, you can say that as well. And when you do, it does become a positive exponent. So what you're going to find out is you cannot leave any answer with a negative exponent. Negative exponents must always be simplified. Okay, as we've done in the past, let's take a look at a couple of examples and give us a chance to practice our law. Okay, here comes the first one. Well, the first two, I guess. 5 to the negative 3. How can I rewrite that as a expression with only positive exponents? In other words, how can I simplify that thing? Well, we just learned that if it's got a negative exponent, you just rewrite it in the denominator with the positive exponent. So 1 over 5 to the 3, which is 1 over 125 if you decide to do the math on it. Now, x to the negative third, same thing. Just because that's a variable for our base doesn't make a difference. 1 over x to the third. Done. I think I got one more example here for us to try. Let's take a look at this one here. Now, what's different about this is that there's a negative exponent on the y, but not on the x. The x's exponent, keep in mind, is 1. So only the base with the negative exponent needs to go down into the denominator, not both parts. So we're going to keep our x on top, and we're going to put just our y to the fourth on the bottom. And again, let me repeat that. It is the only piece in this that had a negative exponent. So that's why it moves to the denominator, and the x stayed on top. Really important to remember. Okay, for our last couple of examples, we're going to see a division problem, or a couple of division problems, where we do end up with a negative in our answer. And knowing now that we can't leave it that way, we're then going to simplify. Okay, so this looks familiar to what you would have seen when we did the division law. So we have some coefficients here. Those numbers can just simply be divided. So 24 divided by 12 is 2. Now that's going to give us x to the 4 minus 9. And 4 minus 9 is negative 5. Now I can't leave my answer like that. So what part goes down into the denominator? Only the one with the negative exponent. So this will end up as 2 over x to the 5th. Okay, that 2 does not belong down there because once again, as a reminder, the 2 has a positive exponent. It is 1, so it's going to stay up on top. All right, one more, and then I'll let you go ahead and get into your classwork. Okay, this last one, another division problem. Let's do our coefficients. 15 divided by 5 is 3. X squared divided by x to the 7th is 2 minus 7, which again is negative 5. And y to the 3 minus, if you need to, that's a 1 there. So 3 minus 1 is 2. Now there's a negative exponent in the problem. So we must simplify that. This is the part with the negative exponent. So the other stuff will stay on top. So 3y squared will stay in the numerator. And we'll move the x to the negative 5th to the bottom, but it will become positive. So 3y squared divided by x to the 5th. It's that simple. Okay, now we all know the reason why. We could go back a couple of slides and replay this video to show why this happens. But there you have it. If you end up with a negative exponent, put it down into the denominator and make it positive. All right, good luck, and we'll see you next time.